Hi everybody and welcome back to CoderDave. Today I have a special video for you. In fact, I've recently delivered a presentation about the Microsoft DevOps journey and I thought I could share it with you. If you've ever wondered how Microsoft does DevOps at enterprise scale and how the DevOps transformation the company went through looks like, but also what kind of challenges and problems we run into, well, then this video is for you. Before jumping into the presentation, take a moment to subscribe to this channel if you haven't already, and if you want to learn more about DevOps, especially with Azure DevOps and GitHub, just click on the subscribe button below right now and turn on the notifications so you will not miss any new video. But without further ado, let's go to the presentation. All right, so as I said, my name is Davide. You can contact me on any of those means. I think we all know what DevOps is about, but we always want to point out that for us, our vision is that DevOps is the union of people, processes, and technologies. It's not just one of those areas, but it's those areas all together. And to enable the organization to have continuous delivery of value as quick as possible and as reliably as possible. And to do so, there are 5 key practices that we normally take in consideration, which are continuous improvement, collaboration, automation, security, and monitoring and learning. We are going through most of those in today's presentation. Why DevOps matter in general and why we at Microsoft started this transformation? Mostly because we needed a way to provide more value, to be more reliable. And we've seen that according to many of the studies, organizations that are top performance in the DevOps space, basically, they can ship better products faster and have happier customers because they have basically more time and more energy to spend on innovation, on new work, on improving their quality overall, rather than working on remediation, unplanned work, and so on and so forth. So this is the why we started doing so. And with now more regards to the work that's been done in the Azure DevOps organization, we started basically in August 2010. So as of today, we've been doing this for 10 years. And we started from a point in which we have Team Foundation Server version 2010, which, if you're not familiar with, it's our previous application lifecycle management suite that was only on-prem, and of course it was a total monolith. So we started at that point, and then we went through all this journey in which we started saying, okay, what if we make that a software as a service offering? And our very first version, and when VSTS went preview, was basically installing TFS on a VM in Azure, on a cloud service in Azure, and that was the SaaS service. Of course, that was not sustainable, so we had to go through a lot of different things. Together with the software transformation, if you will, we had to go through some other bigger transformations. We started doing what our CEO called at that time 1ES, One Engineering System, which basically brought together the best engineers on working on all our engineering practices and tools inside the organization. That started in June 2014. We joined the Linux Foundation, and I will talk through those points better in the next slides, but we kept evolving our practices, we kept evolving our culture, we kept evolving the way we work and the way we deliver software, and we started embracing open source as well throughout the journey. Just to give you an idea, this is slightly outdated as data. It's much bigger now. This is for the broader Microsoft. We had about 110,000 active users as Microsoft organization, more than 5.5 million builds per month, with a total of about 85,000 deployments per day. This, of course, is not only production deployments, but it's deployments in dev, test, and so on and so forth, with more than 25,000 Microsoft employees that are actually contributing back to open source, because one of our philosophies is we use open source, but we want to contribute back to open source as well. We have almost 9,000 open source repos on GitHub for many different technologies across the organization. We are quite active in that. And that is also one of the things that inspired our transformation, I think, because we started working differently and we started adopting new practices and new tools, but also new culture beats. Now, talking more about the Azure DevOps engineering, the team is about 850 people, split in about 45 feature teams in 4 primary locations. We have people in other locations, but it's mostly 3 locations in North America and 1 in India, just to give you an idea of the size. And I go very quickly with this, but the way we work now is we have 3 weeks sprints, and every 3 weeks we deploy or we release a new package for our cloud service, which is Azure DevOps. And every 3 to 4 months, we normally have a consolidated update for our server product, because we still maintain the server product, which is the Azure DevOps server. And as you can see here, it's basically the same code base. So the same bits that go into the service product we have, every 3 to 4 months, they are consolidated and shipped as a patch or as an update or as a major release for our server product. Of course, this has some challenges. I will talk about these later, but it's basically the same code base. Of course, this was not like this when we started. We had actually a 2-year period between different releases in which we had a planning phase and 2 milestones phases. And the planning phase that used to last for many months ended when we allegedly knew exactly what we had to build and we knew that it was right. And then after that, we actually started coding and making tests and stabilizing, bug fixing, and so on and so forth, reaching a point in which after coding, we had the code complete, if you will. And what that was a so important milestone for us, because it lasted for many months, that we used to throw a party for celebrating that, oh, okay, we completed all the code. But it was, many, many months before we actually shipped the release. So after the first milestone, we used to ship a beta. And of course, since we knew that our planning was perfect, we knew that we had a perfect product, and we knew that we had a perfect schedule ahead for fixing the minor bugs and release the final product. But what often happened is that after releasing the beta, the customer feedback was that, yeah, well, that works, but maybe we can change this, maybe we should do this. So we often realized that we didn't get quite the product we wanted or our customer wanted. The problem was that because of our schedule, we were already pretty booked on the next months, because we had just to do stabilization, bug fixing, etc. We didn't actually have time to implement new features or to change the feature we implemented. So usually the response to our client feedbacks was, yeah, we're putting that. I mean, we know we have to do that, but we're putting that in the backlog. We will have it in the next release. But the next release was more than 2 years out. So how well that work? Well, at that time, was not that bad. I mean, saying it right now, it's ridiculous, right? Everyone would laugh if a software provider say, yeah, I'll give you this feature in 2+ year time. But at the time, everyone was doing more or less the same. So it worked quite well. But of course, again, it's not something that is sustainable now. So we had to change because the market changes, our customer changes, and so on and so forth. So what changed? What allowed us to go from a very traditional waterfall monolith model to what we're doing now, delivering every 3 weeks and so on and so forth? Well, basically, everything changed. I'm going through some of those changes in today's presentation, but one of the key changes is culture. We had to change the way we think, we had to change the way we work, we had to change the way we approached problems in the market. Now, this was just the introduction. Let's start talking about more beefy things. And let's start with telemetry and metrics. And let's see what we do measure and what we don't measure. Before going into that, we need to understand what our definition of done is. Everyone has a different definition of done in the market, but our very specific definition of done is that a feature to be considered done should be, first of all, live in production, collecting telemetry, and proving or disproving the starting hypothesis. Whenever we create a new feature, we start with an hypothesis, and we need to prove or disprove that hypothesis. And to do so, we need to have telemetry. If a feature, even if it works well and it's in production and everyone uses that, it's not collecting telemetry, for us, it's not done. We need to have telemetry. So what kind of telemetry we have? Well, we collect a lot of data. We collect a lot of data from the platform itself. We collect data from the usage of the platform for how our clients and our users use the platform, and performances as well. So since we collect a lot of data, I don't know if you can see here, but it talks about almost 2,000 terabytes of data ingress per day. We started with actually with SQL, but then in the long run, that was not was not the tool for it. It's a pretty good tool, but when it comes to this volume of data, was not that viable option. So we actually created in Azure DevOps Engineering a software for collecting and analyzing data, which at the time was called Project Custo, but then it translated to a broadly available service that now is known as Application Insight and Application Insight Analytics. So that service came from the Azure DevOps Engineering first. And what this allows is collecting all this data in a single location with, it's a high volume ingestion engine. It allows us to query really fast over this super huge amount of data to be able to get our, telemetry analyzed in a meaningful way. So the learning for us was use a tool that is purposely made for this kind of data ingestion, because if you need to wait for days or even weeks to have an analytics out of your data, then it's kind of meaningless. So going back to what we do collect, we try to collect data that is meaningful for everyone. And we do not track things that basically aren't delivering value either for the individual teams or the broader organization. And all those data then is translated in dashboards and even in scorecard for our engineering. So every team and at the engineering group as a whole knows where they have to invest more, if it's in technical debt, is in performances, or maybe usability and so on and so forth. So again, what we do monitor? Most of the things we monitor are actually somehow customer related or customer value related, meaning that we monitor what our clients use, our user use in terms of new features. Are they used well or received well, or other features that maybe we changed, how the satisfaction is. We get this data from both the platform itself, the feedback possibility that the user can give in the platform, but also from surveys and other ways like the developer community and so on and so forth, where our client can express their thought. So that is a very important part, because when you're building a product, you need to know how the product is received, what the users like or don't like. And then this is not only for, of course, public product like ours, but it applies even for internal products, because if you're building a product for your internal users, you want to know if you're giving value to your organization, right? So those are kind of metrics that are really important for that part. But on the other side, you also want to know how much time and how much resources you're using for giving that value to your clients. So things we monitor are like the time to build, the time to test, to deploy, and to learn from what we do. We have some metrics and some parameters, and we will see this later, about how fast a test should run in our development environment, or how fast and how much time we spent in building products. It happened in the past that we discovered that our build process was slowing down, so we stopped some of the feature work we were doing and got back to our CI system and tried to see why that was happening, and eventually solve the problem. And now our CI is running much faster than before, because we want to be able to test and to build as quick as possible to deliver the maximum value to our clients, so or to our users. So if that's not happening, we need to solve that problem. And same for deploy. Again, I have a part on deploy later, but we want to be able to deploy during business hours with zero impact or zero downtime. So deployment time is really important, because if the deployment takes 6 hours, then it starts impacting or may impact the production and so on and so forth. And a very important part for us is live site health. We have a live site first mindset, if you will. So everything is around live site. Live site is our first priority. And again, this is because we are having a SaaS service that is used by millions of users, but it applies also to internal software, because especially if you have core services you are developing for your organization, you want and you need those services to be up and running the whole time. And so to assure that, we monitor a few things like the SLA. We have some SLAs that we need to respect, so we want to be able to do so. But we also monitor, in case of incident, and this is really important, what the impact was from the incident to us and to our clients. How much time we spent to detect, to mitigate the incident, and also to have communication with our users, because we believe that we need to be transparent in order to be trusted. Those are all metrics that we think important. There are, of course, things that we do not monitor or we do not mandate, meaning that all those metrics are kind of things that every team in the engineering group must monitor. And this is the minimum subset of metrics that goes into our definition of done. Those are things that if they are not present, then that feature cannot be considered done. What we do not mandate is the red box. So we don't actually care of line of codes or number of bugs found or what was the original estimate against the hours that have been completed to deliver that feature and so on and so forth. Those are things that individual teams can decide to monitor for themselves. They are not part of the metrics we consider essential for the features to be considered complete. Because in the end, those things are not providing value to the client. Of course, it's important to know, what the status of your code base is. But if you have a lot of bugs in your code in your code and you deploy that, apart that we have mechanisms in place to avoid that. But even if you do so, then all the other metrics will be affected. So you will see the customer satisfaction going down. You will see the life site health being affected. So we indirectly monitor that, if you will, at a broader level. And another thing we do is we really focus on our client, as I said before. So we measure availability not only as a global platform, but we do so also by individual organizations. And if we've seen there's a problem for some specific accounts or organization, we proactively reach out to them saying, we've seen you've been affected. We try to collaborate with the client to solve that issue. Of course, we do investigation first and we do so, but we proactively reach out to the client to inform them and keep them in the loop. All right, let's talk about shift left on quality. DevOps is about moving faster and deliver more value, but moving faster doesn't really matter if the speed is just the goal. The speed is not the goal. The speed is delivering more value quickly. So if your deliverables are broken, if you're having a lot of bugs, if you're having a lot of problems in production, then the fact that you're doing it faster doesn't really matter. How we try and solve that problem? But first of all, we started changing the way we work in terms of branching strategy. We ended up adopting a trunk-based development model. One of the main pillars for this is, or in our organization, is that master must be always shippable. So at any point in time, if someone has to deploy to production, he should be able to take the code from master, deploy that to production, and that should be working just fine. How we implemented that? Well, again, we went to a trunk-based development model with very short-lived topic branches. We do not have long-lived branching. We don't do, Git flow, for example. We don't believe in having long-living branches because at the end of the day, especially for big organizations, that causes what we call merge hell. And if you're doing so, you probably know what I mean. Because the higher number of commits or changes you have in a branch, whenever you have to merge that with other branches, you will have a lot of conflicts. So to avoid that, we use very short-lived topic branches. And then as soon as possible, as soon as that makes sense, we merge back to master. And doing so, it avoids us a lot of conflicts. There is still some conflict, sometimes that's unavoidable, but it's much, much less. And it allows us to deliver quickly and to have the merge always, the master or the main always shippable. As you can see, apart from the topic branches, we do have release branches. And these are slightly, they live slightly longer than the topic branches. But the reasons why we have the release branches is because our deployment process can take up to a week or so. And I explain why this is when we talk about release. But we want to be able to be consistent across deployments. So if we deploy today in one of the environment, we want to deploy exactly the same thing in the next environment or in the next environments throughout the week. And we keep the release branches for a while, but then as soon as it's safe to do so, we also delete those branches so they are not going to create, mess, if you will, or confusion in our repo. And when it comes to hotfixes, since our master should be always shippable, even if it's for a release that is deploying, the hotfix normally come from master. We do the hotfix, we merge back to master, and then we cherry pick those features or those changes into the release branch as needed. Most of our repository is monorepo, meaning that we have all the components that are related to Azure DevOps in this case in a single repo. Of course, we have policies and we have mechanisms in place to deploy only one service instead of the other, or to work on or to test the relevant parts, but almost all of our code for the Azure DevOps product in both service and server live in the same repo. Of course, we use pull requests, and pull requests for us are, of course, a point of code review. We require code review for each and any pull request, but it's much more than that. We have testing, L0 and L1 tests. I'll explain in a second what that means. But we have those two categories of tests performed in each PR before the merge to master. And in each PR, we also have compliance, security scanning, credential scanning, vulnerability scanning, and so on and so forth, to make sure that whatever we merge to master is safe and without bugs. And this is also what ensures that our master is always shippable. We have, specific reviewer, all the infrastructure in place, and you can see also on the screenshot of the actual pull request there how we configure that. We have some required policies, we have some optional policies, but the main thing here is that with the pull request, we were able to shift left testing as much as we could, in this case to pre-merge. And this also makes the CI build from master failing very rarely. If it has to fail, we prefer failing as early as possible in the pipeline. So we want to fail if we have to at pull request. We don't want to fail at CI from master. And that also allows us to accelerate the inner loop of development, because it's much safer and easier to work this way when you know that everything you find, for example, in the main branch is properly working. For this pull request, we have about 78,000 tests that have been run against this specific pull request, and it took only about 20 minutes, and we had a 100% pass percentage. So this was probably a big pull request. It probably involved more than a single service or more than a single feature. And so we had a ton of tests run against this to make sure that everything was okay. And this was even before merging. Then when we merge, the developers can spin up a partial environment, and I'll talk about this later, to test the changes. So to make sure that even at a manual level, if you will, we know that everything is okay. So if you see here, we have more than 78,000 tests run against this specific PR. So how is that possible in only 20 minutes? Well, we decided to invest in quality, starting with these 4 pillars. We wanted to have the quality owned by each team. The test should start in development and continue into the real world. And I have in a second what that means. And tests must be fast and reliable. So in February 2015, when the product was still called VSTS, and that's the name that remained, we had this situation here on the left. We have very few L0 and L1 tests, and again, definition in a second. And we had a lot of L3 tests, which basically means we had a lot of fully integration tests, end-to-end tests, UI tests, and so on and so forth. And that was not sustainable, because you cannot run those kind of tests for each and every PR in that amount of time. And that's what we wanted to do. So we decided in February 2015 that we wanted to go from the situation on the left to the situation on the right. So having a lot of unit tests and much less other kind of tests. So we came out with these 4 principles to allow us to do so, which are that the test should be written in the lowest level possible. L0 are the lowest level, basically the unit tests that are in memory only and should execute within I think if I'm around 2 milliseconds. We have to write tests once, but being able to run those tests anywhere, including production. The product itself has been changed, or had to be changed, to be designed for testability. We had to add endpoints, and the code itself should be designed and written for testability. And most importantly, the test code for us is now product code. One of the main things you want in your test framework or in your test in general is to be reliable. If you have a test that runs 10 times on the same code base and maybe 8 times it's green and 2 times it fails at code base parity, then that test is not a good test. It should produce the same result every single time at a parity of conditions. And that's also one thing we had in our code base. Our L3 tests not only took a lot of time to run, not only were too complicated to run, but also they were not reliable, and that was not good, and we had to change that. So before going into how we changed it, let me talk about the test taxonomy. So we've seen already L0, L1, what those are. L0 is, as I mentioned, in-memory only unit test with no dependencies. And then we have L1 that are, again, unit test, but with a little bit more complex requirement. And that requirement or that dependency is normally SQL. Because for us, coming from an on-prem product at the beginning, still, as of today, we rely a lot on store procedures. So we have a lot of logic, business logic in the store procedure, and we want to make sure that that business logic is running properly and is tested. So we treat them as unit tests, but we allow those tests to have a dependency, especially on SQL or for some other parts in file system. And then we have L2 and L3 that are functional tests. L2 are tests that can be run against testable service deployment. And what that means is that our developers have the opportunity to bring in a partial environment, a partial product. We have developed internally a tool that loads for you all the dependencies, but only the dependencies that service needs. So you have a much smaller footprint on your test machine or your dev machine to be able to test. And L2 tests run against these kind of testable service deployment. And finally, we have the L3 that are more complete integration tests that run against full environments like end-to-end tests. But in those cases, they are kind of restricted in the sense that we don't want those tests. We allow those tests only for specific scenarios in which we need to be sure that the end-to-end flow works. As you can see here, I never talked about UI tests. And I want to spend a minute on this because it's very important. We do not have anymore any automated UI test. Now, I'm not saying that this will work for you or for any organizations. This is very important. But the reason why we do not have any UI automated test is because, first of all, it's very hard to execute that in like things like PR. It's very hard and costly to maintain because if you're doing UI automated testing, you know that whenever you change the position of a button or you change anything in your UI, you most likely have to touch some of the UI tests. But the main reason why we don't have UI tests is that because we are the first users on our platform. Whenever we deploy, the first deployment is for us. We use Azure DevOps to create Azure DevOps. So as part of our dev and PM teams or engineering teams as a whole, whenever we deploy to our environment, to our production environment, then they start using that. And it's really easy for us and really quick to identify if there is any problem because we use the product day in, day out to create the product itself. This is the reason why I said, I'm not saying this approach works for every organization on the planet. If you just do software for someone else and you don't use that software, most likely you're not going to find the problems or you're not going to test the UI the same way we do. And in that case, you probably want to have some automated UI test or QA department. That is something that, again, we don't have. We don't have for Azure DevOps a formal test and QA department. All the test is done by the developers and PMs because we use the product directly. How did this change? If you see in the very left is the very first sprint when we started our test transformation. It took us 2.5 years to go from the very left to the right, in which, as you can see, we went from 2,000 unit tests to almost 80,000 unit tests. I think now is more than 80,000. We started introducing the L1 test. We started introducing the L2 tests. And we completely got rid of the TRA test. We have few L3 tests. So now we have all the tests we need to have the confidence in the quality of the code. But now most of them are run continuously, every PR, every build, every CI during the development cycle. And that assures us that the product should be as good as possible. And as you've seen, we are able to run 78,000 plus tests in a matter of like 20 minutes or so. Even more importantly, now green means green and red means red, which means that, as I said before, we had tests that used to fail under the same conditions for no reason. Now we know that all the tests we run are either green or red. So or they fail or they succeed. And if they succeed, means that they are really succeeding. And that allows us to move on with a code base that is as healthy as possible. But of course, we don't test only in our code base. We also test in the real world, going through a series of environment, of which I will talk about more later. But that allows us to do basically testing in production for each and every feature we deploy. let's talk about security, because again, we invested in quality. Quality doesn't matter if your client don't trust you. Sometimes when people starting adopting DevOps, or when organizations start looking into DevOps, they said, "Ah, no, we cannot adopt DevOps because there's no enough security in DevOps or cloud practices." Well, actually, that's false, because proper DevOps actually help in security and should help in security. I'm not a big fan of terms like DevSecOps, even though it's a good way to categorize something. But I truly believe, and we truly believe, that security must be part of the DevOps practices in general. And for us, what we did is basically embedding security in each and every area of our DevOps process. As I said before, DevOps is people, processes, and technologies, and we have security, and we needed to have security in all of those. Starting from the education of our developers and PMs, with the mindset, as I said before, we change our culture. So a mindset of assuming breaches, protect credentials, and so on and so forth. Going through processes in which we say, okay, we need to be secure. So what we can do, we can adopt a like SDL style or model, create threat modeling, security assessment, red blue team exercise. And code review is a very important part of our security as well, because we make sure in there that the code per se is secured. And of course, we back that up with the technology. So things like release automation, infrastructure as code, static code analysis, all those tools, security management, vulnerability scanning, so on and so forth, that are supporting what we implemented as a process due to our changing culture and where security could start. One very good example is when we started doing security, we started with assume breach, and we started, as many organizations do, having a red team and a blue team exercise. If you're not familiar with this, red team is a team inside your organization that try to break things, try to hack your software, try to penetrate and steal things from your environment. While the blue team is a team that does exactly the opposite. So try to fix things and identify and fix things before the red team is actually able to do some harm. We started with this, and we soon realized that it was not the most efficient way to do so. It was working, but it's not probably the most efficient, at least for our reality. So what we did is we completely took away the blue team, and we spread the component, if you will, of the blue team inside every single feature team. So now we completely shifted left the security part, and we have automated tools that can help us in that, like the credentials, secret leakage, and OS. But each team is responsible for the security of the product. So each developer should be able to write the code, write the tests, and check for security vulnerabilities, and write the code in a way that is secure and reliable under the security standpoint. And of course, through the code reviews, we can also make sure that all the best practices and all the security guidelines are respected. We still have the red team that try to break things up, but we don't have blue team. Each our feature team is also a blue team, if you will. And to do so, of course, we had to change our process. Now we have security throughout the whole process, because security work is taken into the sprint, is part of the sprint planning and the backlog grouping. Everything is linked, so we know which feature respect what security item, and so on and so forth. As I said before, as part of the PR and the CI in the PR, there are security, vulnerability, and policy scanning, and as well as in the continuous integration build from master, security and vulnerability tests that must be 100% successful before we can move forward. Last but not least, we have progressive deployment across stages with release gates, and some of those release gates are specifically tailored for security. I think the main takeaway is from this slide, we have, and I think everyone is, in my opinion, to have security basically embedded from start to finish in their process. Technology and tools are there to help and are super helpful, but if you don't change your process around security, and if you don't change your mindset for security, then the tools themselves can do much less than their full potential if you have all of those things in place. And finally, let's talk about release strategy. We are deploying things in two different categories. If you remember, I said when we started with DFS, we had a single monolith. that single monolith still exists. However, over time, we started breaking that up in some microservices and services, or we started adding new features as collateral services instead inside the monolith. So when I say we deploy every 3 weeks, that mainly apply to the monolith, but it's true that we release every 3 weeks, which means that even if we have microservices, and maybe with the microservices we deploy way more frequently than with the monolith, we may deploy even daily. But then when we enable the features for our users is still on the 3 weeks cadence. This is important because it's somehow easier and not easier deploying every day and having zero downtime, and deploying every, during working hours. When we talk about monolith and microservice, we have a mix of the two, and we need to make sure that both of those respect this principle. And apart from the timing, we decided to use the exact same tools to deploy to production and to deploy on the individual development environment for each single developer. They have to use the same tools, so we make sure that there's consistency and everything works properly. We want to make sure everything works. So we have metrics and monitoring embedded in all our process. So all those signals, especially related to quality, are tracked constantly every day. So how we do achieve that? We do use feature flags heavily. When I said we take out from master, and master is always deployable, is because we use feature flags, which means that even if a feature is on master and is not code complete or is not functional at a level that we want to enable that for all our users, we still deploy that piece of code, because anyway, we are sure, because all of our testing and so on and so forth, that will not impact the overall quality of the software, especially if the feature flag is turned off, because our user will not hit that piece of code. I'm sure everyone knows how feature flag works, but you can take it down to a if in the code. So if the feature flag is on, execute this part of code, else use this other part of code. As simple as that. Our feature flag mechanism is internally developed and embedded in the product. We can control the whole organization, the whole Azure DevOps to turn on and off some feature. We can go to organization level, to account level, or even to single user level to turning on and off some features. And that happens at runtime without the need of redeploying or anything. We can do it via PowerShell or via UI. And those allows mainly 3 things. First of all is zero downtime and smooth deployment, if you will. And of course, enables dark launches of features in the same manner. Feature flag is not magic. Not every time everything goes well, but we learn from that. So there was a specific case, and I'm pretty sure you may know this already. We had a big event that we participated into, and we wanted to enable a bunch of features during that event. So just before the keynote, when Brian Harry was about to reveal those features, we turned the features flag on, and it didn't go really well. The product really crashed, not because the feature code was a bad one, but because we never tested that under load. So when we announced that, the whole world connected to Azure DevOps to try those things out. And since we didn't have a proper load test, we had a DDoS on our service, if you will. So we learned from that, and now we never enable features at the moment of the event or the announcement. We normally enable that in advance, so we are able to test them under load. We are able to make sure that everything is good, and then whenever we actually announce them, or whenever we are ready to publicize them, we know that they are well tested. Another thing that really helped us is the complete automation of the process. So of course, when we started the release process, we had a lot of manually run commands. But now in the process, we came to realize that failures in manually run commands happens pretty often. So we decided to go for full automation whenever possible. So even if there are PowerShell scripts or other interaction that the system need to have in order to be deployed, then everything is automated in our release pipeline. Everything must be run in an automated fashion through the pipelines. Everything happens every time, so everything must be idempotent. Any part of deployment that must run, that must be idempotent. So I should be able to execute that as many times as I want, and having the overall same result at the end. And of course, everything is orchestrated with Azure pipelines. which is very interesting because we, as I said, use Azure DevOps to deploy Azure DevOps and to create Azure DevOps. So sometimes it's been challenging deploying pipelines while using pipelines. We solve that, and we will see it in a second, splitting the deployment in different parts. So finally, as I said, we use different environments we call rings, and all the rings are production. We go from ring 1 to ring 5, and we deploy to ring 1 first, and then we wait, we deploy to ring 2, and then we wait, and so on and so forth. And between rings, as I mentioned before, we have the release gates. We have some kind of automated tests that run against the deployment to make sure that everything is correct. And then we also may have some manual approval that is required or can be used for slow down the process if we identify that something is not working as expected in a specific ring, and we want to see why is that happening without continuing the deployment. And this, of course, gives us visibility into the impact of every deployment in every and any environment. So to explain a little bit better what this is and what the deployment rings strategy is, we start always from ring 0. Ring 0 is a high tolerance ring, meaning that even if something doesn't work, it's not the end of the world. And the reason for this is that because it's internal only. This is the production for most of Microsoft accounts, including Azure DevOps organization. So this is where the very new features go first, and we can test them basically in our day-to-day work. When we are fairly sure that everything is okay, we can progress to ring 1, which is normally a small data center for Azure DevOps, in which there is a breadth of products. So we want to be sure that we are not overloading the new features or the new deployment, but we want to still test every single part of Azure DevOps. More than test, I should say, get information out of the platform, get metrics out of the platform. Because remember that if ring 0 is internal only, after ring 0, so even ring 1 is public users using that. So you need to be part of our early adopter programs to be in ring 1, but it's still real clients using the product for their real, maybe core business scenarios. After that, we go to ring 2, which again are public accounts, and it's normally medium to large data center. Ring 1 and 2 is US time zone only, because the main engineering is in US. So we want to be able to be present as engineering if anything goes wrong. And this is why we deploy during business hours. Ring 3, instead, it's not anymore in the US time zone, because we talk about European data centers. And in this ring, there's also the larger internal accounts, like the Windows team, for example. Windows team is so important. Windows and Office are so important that we don't want to have them in the ring 0. We want to have them in a higher reliability ring, if you will. And after that, we have the ring 4 and ring 5 that are basically everyone else. It's also important looking at the way we deploy. First of all, apart from the big time, we deploy in 2 different moment for each ring. We deploy the binaries, and only after a specific amount of time, we deploy what we call servicing, that mainly means our database, which means that if we deploy the binaries first, those set of binary must support the current database schema plus the new database schema that comes with that deployment, because the new database schema will be applied hours after the binaries are deployed. And this is very important because it's much easier to roll back if you have with binaries, but it's much more difficult to roll back a database schema. And in fact, sometimes we do have to roll back the binaries, but we never roll back the database. When it comes to database, we always try to roll forward with a new deployment to make sure that everything is okay. Between the binaries and the database plus the other components, there is a delay. Now, I'm not sure this number of hours is still accurate. I think it's slightly longer now because the platform is getting bigger, but it's still not a big amount of time. And the reason for that is that because, especially in ring 0, we have tens of thousands of engineers and PMs working on that platform for a continuous amount of time. So if there's anything wrong, it's very likely that something comes up very quickly. And then we have a delay, which I'm sure it's now much longer than this time, between different rings. And this is the reason why, as I said in the beginning, we create the release branch, because our release can take like up to a week or so to get from ring 0 all the way to ring 5. And last but not least on this, inside each ring, there are multiple scale units. So when we started, we had 1 scale unit for our monolith. and one scale unit for our shared platform service, that is authentication and so on and so forth. But now, of course, we have multiple scale units, we have multiple data centers, and of course, we introduce also the microservices and containerized services and other supporting services along the way. So we deploy that in a slightly different way. As I said before, we may deploy that even daily, but at the end of the 3 weeks, we do enable their release. So the very last thing we're doing is we're adopting some of the GitHub features. But the reason why we're going to adopt GitHub is that we want to embrace open source. We already embrace open source. We want to do even more. We want to ensure that we use open source in a secure and compliant manner. And we already have like 20,000 people, more than 20,000 people working on open source project. We want to leverage even better inner source. Inner source in Azure DevOps is okay. Inner source in GitHub is top notch. So we are going to use these more and more also for our Microsoft internal products to be able to do inner source, and especially to take advantage of advanced security. The capabilities of GitHub in advanced securities are much bigger than other products. So, and we have everything in there. We are starting and we want to continue to implement and to use those tools, including that basically are including the GitHub advanced security into our process. And that's the reason why. So again, there's a lot thing to do. It's a process that is going to last. It's already going for 10 years and is not finished yet. The things we want to do is apart inner source with GitHub and security, but also start implementing more and more chaos engineering practices. That is something that we lack of as of now. And of course, continue to improve in the journey, which is not easy. It's not magic. It takes a lot of effort. It takes a lot of work. But for us, it's worthy because we've seen the quality of our product going up. We've seen the number of features we are able to deploy and the satisfaction in our client base being much, much higher. And with this, I'll stop. I'll talk too much. And I'll thank you for your attention.